All right, everybody, we are back and I'm on page 224. And what we're going to do is we're going to talk about finding distances in 3 dimensions. And a fun little fact for you, I already recorded a 60-minute version of this and forgot to turn on the microphone. So I'm doing it all over again. And isn't that joyous? All right, so what we're going to do is we're going to go through how the formula, like where it comes from, because I think it's important. I could just give you the formula and you could use it. That would be not great because we want to keep moving forward. And to do that, you have to really understand how 3 dimensions work. And I find that you orient yourself very well if you spend a little extra time at the beginning just thinking about like where are points, because it's not obvious, right? So the point we want is x0, y0, z0. So it's this point up here that I'm kind of like, filling in there. I'm actually not going to label that one though, because it makes our figure really cluttered if we do that. But what I'm going to do instead, so x0, y0, z0, it's like it's on the ceiling directly above you. What we're going to do is we're going to drop down to the floor. The floor is the xy plane, so z is equal to 0. We're going to label this point as x0, y0, and then z is 0. So we're going to label that. Okay, now let's think. This is the y-axis. And this is the x-axis. And so to get to that point, the point x0, y0, I know that I had to move x0 units on the x, why would I say the y-axis? x0 units on the x-axis. So this point over here must be the point x0. We're on the y-axis, so 0. And then the z value, we're in the xy plane, so z is equal to 0. Also, I just messed that up. We are on the x-axis, so y is equal to 0. So that's why y is equal to 0. Come on. We're obviously on the x-axis. All right, and then z is equal to 0. So we got that. We could do the same thing on the y-axis, right? So we are on the y-axis. So think of the 2-dimensional xy plane. If you're on the y-axis, the equation is x equals 0. So at this point, I'm at 0. Definitely y0, and then z is 0 because we're in the xy plane. The origin I'm not going to label because it just kind of like, it's a little too much. So that point was that. All right, now let's think about the point directly above. So this point up here, the point directly above x0, 0, 0. So you're at x0, 0 in the xy plane. And then you're going to get on the elevator and you're going to go up z0. So to label this, we can do x0, 0, and then z0 because we went up. Same thing above the point 0, y0, 0, right? So here we went up, so we're now going to be at x is still 0, y is still y0, and now we're all the way up at z0. And then finally, we have this point here, not the point we're interested in, this other point. So what you could do, it would mess up your picture. You could put in lines and complete the rectangular prism if you want. It's like not a bad idea. It'll mess up your picture though, so it is a bad idea. But okay, so if I'm on the z-axis, that means that x is definitely 0. It means that y is definitely 0. And it means that z is whatever z is. So it's z0. And then the only point that we didn't label in this picture now, other than the origin, is the point we're interested in. So I didn't even label that one because it's just gonna like mess everything up. So what we'll do now is I'm going to take this rectangle that I'm kind of highlighting here. I'm gonna take this rectangle. Whoa, iPad slid. Okay, take that rectangle. We're going to move it and transcribe all of its points over to here. So I will do it for you. x0, y0, 0, 0, y0, 0. This is the origin. So 0, 0, 0. That kind of looks like a theta. It's a 0. And then x0, 0, 0. Okay, so what I now want to find is I want to find, let me use this color. I need to find this. And so what does this correspond to in our picture to the left? It corresponds to this. And if you're thinking to yourself, I've seen that before, that's come up, it's come up all the time, right? That's what we called R in polar coordinates, or the hypotenuse of a triangle, like whatever you want to do. So the length of this, so I'm going to call it R for now, is you're in the xy plane and you're essentially finding the distance between the origin and the point x0, y0. So you know how to do this. It's going to be the square root of x0 squared plus y0 squared. Okay, so we have that. We're going to keep moving. So what I'm going to do now is I'm going to do this triangle. So where is this triangle in our original picture? Let me highlight two more things. So I'm going to highlight this. And then I'm also going to highlight, what colors am I using? I need another color. This. Okay, so where are those in this picture? We've got the orange thing is R. That doesn't really look orange to me, but you know, deal with it. We've got the, I forget what color thing I'm using here. Greenish thing. Still, I'm looking forward to everyone telling me that it makes them seasick when I move the PDF around. Looking forward to that. And then what color did I use for this other one? Yeah, I think I used that one. That's one of the things you do a lot when you're making videos is you just like use the color again next to the color you're trying to match and you see if it's the same. Or maybe other people are better at this. Also a possibility. All right, so this segment right here is R, which we found was a square root of x0 squared plus y0 squared. All right, what else can we glean from this? So this point, I'm gonna label the points. x0, y0, 0. This is actually the point we're interested in. This is x0, y0, z0. And then this point over here is actually the origin, 0, 0, 0. And we're trying to find this like bluish segment. I'm going to name this segment. So I named the segment in the xy plane R. So I can't name it R, even though it feels like it should be the radius of something. So I'm going to name it rho. And rho is something that, so rho, all right, let me draw it. It looks sort of like a lowercase p. It's R-H-O, it's a Greek letter. So later in your life, we've talked about rectangular coordinates. That's what we're doing right now, x, y, z. So think in 2 dimensions. You had rectangular, x, y, but then suddenly polar came out of nowhere, right? And you have r and theta. There are 3-dimensional equivalents of both of those, but polar is a little more complicated, a little more intricate, right? Rectangular just becomes x, y, z. You just add like, you're moving up and down, big deal. Polar has 2 different things that you can kind of think of as 3D equivalents. One of those is called cylindrical coordinates, where basically you take polar coordinates in the XY plane, and then you just use Z. You can like move up and down on an elevator. That'll give you some neat looking things. Spherical is the other option. Spherical is like GPS coordinates, where you have a longitude and a latitude and a radius, right? So when you're thinking about GPS coordinates, you don't think about the radius because you're on the earth and it's like not such a big deal, but like it will tell you like your what is it, like your altitude, like your height above sea level or whatever. Like anyway, that's neither here nor there, but eventually you're going to talk about those, and rho is what we use in that. So this is good because you're now this seems to have frozen. Let us deal with this technical difficulty that you don't even know that I'm having. Okay, I stopped mirroring, and then I'm going to start mirroring again, and hopefully it lets me, okay, it lets me move. All right, so it got tired of listening to me, I think. All right, so I have to find rho. So rho, I need one more thing, right? I need this distance right here, if I'm going to find it. But it's like you're at the point x0, y0 in the xy plane, get on an elevator and go up z0 units. So the length of this is just z0. Okay, so we want rho. So here we go. Rho is going to be, it's a distance formula, square root of, hold on. I'm trying to do this thing where I only do that, and then I'm gonna like close it, and it's gonna work perfectly if I do it right. So it's r, which is the square root of x0 squared plus y0 squared. And then we have to square that plus z0 squared. Okay, but since it's square root and then squared, rho is actually just the square root of x0 squared plus y0 squared, and then plus z0 squared, which you might be saying to yourself is exactly what you would have written anyway, like 10 minutes ago, and that is definitely true. So what we did was we found the distance between the origin and a point. If it's not the distance between the origin and a point, then what you do is instead of using x0, y0, z0, you're just going to use like your delta x, your delta y, your delta z. You can still make a triangle out of that. So I'm going to write down my distance formula. So this is like translated to some random point. So if you're into translations, this is a good translation. We're like translating by a certain amount. It's like vectors. You should always be thinking of those. Just always, just every once in a while, just sit and kind of ponder vectors. Come up everywhere. They're useful. Also, this square root thing that I'm doing, I'm never going to remember to always do it, but how good is that? Like, I didn't need to go back and adjust it or anything because I waited until the end. It's a good move. Okay, find the distance between the two objects. They're points in part A. In part B, they're not both points, so I guess that's why it says that. So this one, let's just apply the distance for it. Ah, see, I did it already. So 6 minus -3 is 9 squared plus 2 minus 2 is 0. I'm going to say that I'm squaring that. Plus -1 minus 8 is -9, but I'm going to just use 9 because I'm squaring it. Okay, so you could dive in. You could expand those. A better idea, though, is to say that you have two 9 squareds, which means you have 9 root 2. You should also be able to do this on your calculator. I think that on your calculator, the ideal thing to do is like store this as like A, store this as B, make the vector from A to B, which is just going to be B minus A, and then find the norm of that vector, right? So that's kind of like the cheat code for finding distances on your calculator, is to always think of them as the norm of a vector. All right. So this one, I might come back in another video and kind of GeoGebra this thing for you to like help it make more sense. We want the distance from 6, -3, -4 to the y-axis. So this is hard to think about in 3 dimensions. So let's think about a 2-dimensional equivalent. Say we wanted the distance from the point 6, -3 to the y-axis, right? So the distance is always the shortest distance, which means, color change, go straight across. The point that's on the y-axis that is closest to this is 0, -3. And then we would like do the problem, right? I am here to tell you that the 3D equivalent is exactly the same, except instead of being the line y equals -3 that connects them, it's going to be the plane y equals -3 that connects them. So I need to know, where does the plane y equals -3 intersect the y-axis? And if you think about it, it's kind of obvious. It's going to be when y is equal to -3. So the closest point that's on the axis is actually 0, -3, 0. So this problem just boils down to finding that distance. So that is going to be, I did it again. I mean, if you rewind, you will see I said that I will never remember to do it, but 6 minus 0 is 6 squared, -3 minus -3 plus 0 squared. I'm kind of a big fan of writing those things so that you can like see where your work came from, even though like it's 0, you don't need it. It's not really hurting anyone. So I put it in to like keep the form going. And then 0 minus -4, I kind of forget which order I was doing them in. That's going to be 4 squared. So this is square root of 36 plus 16. Square root of 46 plus 6 is 52. We could simplify that. I don't think there's any point in simplifying it really because it's not going to make it any clearer. So that is where I'm going to stop this video. We took a lot of notes, and I will be back in the next video to do some more math with you. So I'll see you then.